Okay, 2.7 is on partitions. Okay, let's talk about disjoint sets. Okay, two sets whose intersection is empty okay, is said to be disjoint. Okay, A intersect B is the null set. Those are disjoint sets. Okay, a sequence of sets is said to be pairwise okay, a sequence of set is said to be pairwise disjoint if every pair of distinct sets in the sequence is disjoint. If that is A sub I intersect with A sub j is equal to the null set for any I and j in the range from 1 through n, where I is not equal to j. Okay, a partition of a non-empty set A is a collection of non-empty sets of A such that the following are true. Okay, so partition. So the idea here is that we are creating something that's called pairwise disjoint, which just means that there's no overlap between any of the sets. Okay, you take a bunch of elements in the set and you're going to say, well, these two go over here, these three go over here, these four go over here, and there's no overlap. Okay, that's what it means to be pairwise disjoint. Okay, it means that any intersection between any of the pieces that I'm partitioning off, there is zero overlap. Okay. Okay. So the first one is that for all I, A sub I is a subset of A. 2, for all I, A sub I is not equal to the empty set, null set. Okay, it means there's no empty sets. Number 3, A sub 1 A sub 2, A sub n are pairwise disjoint. Okay, it means that everything has distinct elements and they all have different elements. Okay, there's no repeated elements. Pairwise disjoint. And number 4, that all of the subsets combine to create the original. Okay, all the subsets combine to create the original. So, okay, what does this look like? Let's do an example. Okay, it says, look, if we have this set A, and we want to separate this into different sets, we could say, this partition contains elements 1, 4, and 5. This partition down here is elements 2 and 3, and this partition down here is element 6. And no element is in 2 partitions. Okay, that's the whole idea, is that we are partitioning this. Okay. Okay. So there's 3 is not in both of the partitions. We're taking one set and we're piecing it up. We're slicing and dicing up the sets. Okay, up the set A. But we're doing it in a way that there's no overlap between the elements. Okay, there's no intersections of these elements. All the intersections are, okay, are the null set. That's what it means to be pairwise disjoint. Okay, we could say AI intersect AJ is equal to the null set. Okay, so A1 we could say is 1, 4, and 5. A2 we could say is 2 and 3. And A3 is going to be 6. Okay, and these all form a partition of A. Okay, example 2. Okay, if we look at, we could represent the partition as piecing up a number line. Let's piece up a number line. We have, say, 0, 1, 2, and 3 on the number line. We could have an open circle with an arrow going this direction for one piece. Okay, we could have a closed circle going to 3 for another piece of the number line. And then we could have a third partition going from, okay, but there are conditions for piecing up a number line. For piecing up a number line, all values of the number line must be represented, and you cannot have an overlap. So if I had, say, this here, that would be wrong. I can't have that. I can't have 3 in both partitions. Okay, that's why I have an open circle there instead of a closed one. Oops. Okay, so we're going to call this partition B1, partition B2, and partition B3. So all values have to be represented, and there cannot be any overlap in the partition between partitions. So B1 would be represented as X is an element of R, given that X is less than 1. B2, X is an element of R, such that 1 is less than or equal to X, which is less than or equal to 3. And B3 is equal to X, an element of R, such that X is greater than 3. And these all form a partition of what? What do they form a partition of? What's the set that we're going to form a partition? Well, what are we piecing up?
The number line?
A number line. Okay, and what are the values on a number line?
All integers?
Well, a number line is a line, and a line is continuous, not discrete.
Okay.
So this thing goes off to positive infinity, it goes off to negative infinity. So it's not the set of integers, you're close.
All real numbers?
Yeah, all real numbers, thank you. Okay, it's the partition of R. Okay. Okay, and that is